Hey, well, hello, my friends. Here we are. Exercises section 1.4. We're working on pairs of angles, and you've got the problem set there starting on page 31 up above. I'm going to be working with you on numbers 1, 9, 11, 27, 35, 37, and 41 really quick. And so let's jump right in. Question number 1 is something that we covered in the homework, but again, I see are the notes, and I see people getting hung up on it, so I just wanted to walk you through it again. It says an angle measures x degrees. What is the measure of its complement? What is the measure of its supplement? So again, if it's always hard sometimes for students when they start saying something's worth a certain variable, a certain number of x degrees. We like to just know, wait, what is it? 10 degrees, 5 degrees, 20 degrees? Let me know. But what if it's just x? It's a variable. We don't know, but we want kind of a rule that we could follow every single time. Well, if you remember, if you have complementary angles, that means they add up to 90 degrees. So if we have two angles here, they have to add up to 90 degrees. And it's telling us that this one angle is x degrees. What would we say is the other one? Well, if they add up to 90, and I know one is worth a certain number of degrees, if you remember if you watch the homework, it just simply means, well, that means 90 minus x equals my unknown angle, 90 minus x. So the angle that you don't know is always the difference between the total and then the other amount. So although we can't solve that, here's the rule, 90 minus x. And as soon as somebody told you, well, x is 30 degrees, oh, you plug that right in. 90 minus 30 must be 60. So here we go. We would express it as 90 minus x. And then it's the same concept when it says, what about measure of its supplement? So if we have supplementary angles, I'll draw it over here. We have supplementary angles, and we have two angles there, and they tell you, oh, this guy's worth x degrees. What is this one? Same idea, except you're not subtracting from the same amount. It's the total amount here, unlike the one on the left was 90, this one over here is 180. So this would be 180 degrees minus x, would be how I would express this angle right here. This angle is the total minus the x and what's left over. So same idea for both, but it just depends whether it's complementary and they add up to 90 or whether it's supplementary and that they add up to 180 degrees. Okay, we're going to do number 9. Jump to number 9. Question 9 says, find the measure of each of the following, the supplement to angle B. So when you look at the picture there to the right, they've actually drawn angle B, looks something like this, and they've said that angle B is 6x minus, oops, let's do that a little neater, 6x minus 5 degrees. Okay, so
Hi,
if
Jack.
I want to find the,
Do you have faculty meetings scheduled this week?
Sorry, getting phone calls. If we're trying to find the, what are we trying? I got distracted there. The supplement of angle B. So in other words, if this is angle B and there's a supplement right here, and we're trying to find this one, it's the same as what we did there on question number 1. You've got the whole linear supplement is worth 180, so that means we need to go 180 minus the angle that they're giving us, minus the 6x minus 5. Okay, because in this case, in the first case, it was just x, so we just did 180 minus x. Here, it's not just x, it's 6x minus 5. So we write 180 minus 6x minus 5. Notice there, again, if you watch the homework, that you need to put this in parentheses. And the reason that's important is because we need to distribute the negative. In other words, the negative here needs to be applied to negative 6x and a negative 5. So what that actually ends up looking like is 180 minus 6x plus 5. Because you're going to subtract the 6x, but then you're subtracting a negative 5, and that's like adding 5. All those wonderful integer facts to remember. So then this actually simplifies to 185 minus 6x. So this angle here, which I'm sorry, I drew that very sloppily. This angle here would be 185 minus 6x. All right, and again, all we're doing is we're taking the total and we're subtracting what we know. And sometimes what we know is a number like 30, and you could do 180 minus 30. Oh, the other one's 150. Or if it's just x, we do 180 minus x. Or if it's an expression like 6x minus 5, we do the 180 minus that expression. And the thing I've warned you about or advised you to make sure you put that expression in parentheses because you want to make sure your negative gets properly distributed. And if you want to know more, like what are you doing there exactly, let's talk during one of our live sessions or hit me up on Zoom anytime this week. Okay, so let's look at number 11. Number 11, an angle's measure is 6 degrees more than 3 times the measure of its complement. Oh, I used to hate the problems like this. What did you just say? Okay, well, let's look at it again. It says there's two angles here, 6 degrees more than 3 times the measure of its complement. So key there is its complement. That means we have two angles, and they're adding up to 90 degrees. Okay, so let's start with that. And then it's comparing those two angles. It's saying one of the angles is 6 degrees more than 3 times the other one. So whenever I'm comparing two values, I usually just say, okay, well, that means one of these guys I'm going to call x. And what does the other one then compare to? Because notice there's no numbers. It doesn't say one's 40. It doesn't say one's 35. It's all gobbledygook of comparison. The key there is to name one of them x. And then you can compare them. So the other one, it says it's 6 more than 3 times this one. So 3 times this one would be 3x, and 6 more plus 6. So there's the key. Once you draw this, now you're in a situation where like, oh, that's what I'm doing. They are complementary angles that add up to 90, which means they add up to 90. And then always just pick one thing. If it's a comparison problem, one of them is x, and the other one is then 3 times that plus 6, or whatever comparison they give you. Because then we need to find the measure of this angle. Well, I have expressions I need to solve. That means we need to write very good, an equation. Something is equal to something. Don't be tempted. It doesn't mean 3x plus 6 is equal to x. We don't know that, but we do know they're complementary. So we know that together they equal 90 degrees. In other words, this angle, 3x plus 6 plus the other guy, x, maybe gal, who knows, it equals 90 degrees. So when I say something equals something, don't just take the two numbers you have and say, oh, they're equal to each other. No. They might add up to something. They might subtract to something. You might need to double one. Anyway, it just means you need to write an equation. In this case, the clue was they're complementary. So they both add up to 90. So now we just go into algebra mode. We simplify. I've got two sets of x's, so I need to combine like terms. So that gives me 3x plus one other x is 4x. Plus 6 equals 90. Then I need to go ahead and subtract the 6 from both sides because I'm trying to get x by itself. That eliminates the 6. And so that gives me 4x equals 84. The opposite of multiplying by 4 there is dividing by 4. So we're going to divide both sides by 4. That cancels out. And so we get x equals 21. All right, bingo, 21. But they didn't ask for what x was. So my answer is not 21. They asked for the original angle that was 6 more than 3 times it. So that means I'm trying to find that guy right there, or gal, or it. 3 times 21, 3 times the angle, plus 6. Okay, so that's 63 plus 6, 69. It is an angle, so 69 degrees. I check my answer because it's not about just getting it done. I want to actually learn something and know if I did it right, and that is correct. So this is, to me, this is a pretty tough problem, and that's why hopefully you're watching this and that can help you make sense, because you had to go from a couple words, sentences, to then drawing the correct diagram of complementary angles. Then you had to do that tricky step of interpreting what they meant, that there's comparing the angles. There's one basic angle x, and the other one is compared to it as 6 more than 3 times it. Anyway, I won't rephrase the whole problem, but let me know if you have questions on this type of problem, or review this a couple times, because it's a very useful algebra skill. But then, well, anyway, once we had it correctly labeled, we set up the equation, solved, and plugged in. And again, if you're watching or working through your homework each day and solving enough of these, you're starting to feel the pattern, hopefully. Okay, 27. 27, it tells you, always read the black. Make sure you read the section ahead of it, so because a lot of times that has important information. If I just jump down to 27 and start reading, I might be confused. Up above that, it says angle ABD and BDE are supplementary. Find both angles. Okay, supplementary, what does that mean? Are they congruent? No. Do they add up to 90? No, that's complementary. It means they add up to 180. So I don't even necessarily need to draw a picture for this. I know that those two angles, ABD and BDE, make sure I look at the right problem, are supplementary. So that means if one of them is, let's go ahead and go into solving mode, 3x plus 12 plus the other angle, 7x minus 32, they are supplementary, so they equal 180. Okay, and now we can just go ahead and solve that. Again, let me go ahead and back up. I'm feeling guilty. What you basically did is you have two angles here, and supplementary means they add up to a straight line or a linear pair, or 180 degrees. So all I'm doing is saying I'm taking this angle and I'm adding it to this angle, because together they're 180 degrees. And so here's my one angle that I'm adding to the other angle. Okay, I feel better now. Let's solve. We have like terms. How many x's do we have total? We have 10 x's. 3 plus 7x. And then we have our constants here and here. And so we have 12 minus 32. That's going to be for a total of negative 20. And they're still all equal to 180. Notice it's much easier to simplify the side, then you go into balancing and opposite operations. So how do I get rid of this negative 20? I do the opposite. I add 20. Well, that's going to make it nice and round there. Cancels out, always the goal. So I get 10x equals 200. The opposite of multiplying by 10 is dividing by 10. Cancels out. 10 divided by 10 is 1, so I'm just left with 1x. Oops. And so that means x is equal to 20 divided by 1, 20. So I have found x. X is equal to 20. But once again, check the black. I'm not supposed to just find x. I'm supposed to find both angles. So that means I need to plug it into here. And maybe even into here, but I'll show you a slight shortcut, because you can plug it into both, or you can do it the way I'm going to show you. So first I'll plug it into the first one. 3 times 20 plus 12. So that is 60 plus 12 equals 72 degrees. So one of the angles, angle ABD, is equal to 72 degrees. Angle ABD is equal to 72 degrees. How do I find its supplement? Well, I can plug it in, and I can go ahead and do 20 times 7 minus 32. Go for it. That's perfectly fine. Or because they're supplements, I can do 180 minus 72, and I can see that it's just going to be 108. Notice I'm putting the degrees, 108 degrees. And that is angle BDE. Okay, so a very typical algebra-based problem solving with supplementary angles. Notice, I think there's another problem you'll do that they're complementary. The process is exactly the same, but because they're complementary, you'd redo the whole thing, and they would add up to not 180, but they would add up to 90. Okay, on to number 35. These are a little faster, otherwise I normally wouldn't do so many problems, but I'm just feeling excited by math today. 35, this is a true or false statement, and if false, you have to explain why. 35 says, a pair of vertical angles can form a linear pair. A pair of vertical angles, if you remember that, that is the opposite angles formed by intersecting lines. So that means like this and this would be opposite or vertical angles. They form a linear pair. Well, a linear pair I thought was two angles right next to each other. So the question here is it possible for two angles to be next to each other with a common side and a common vertex and be opposite of each other? And the answer is no. No, you can't do that. It's telling me it does not compute. So this is no or false. Because angles can't be adjacent and opposite, or something like that. You could also say something, well, no, we probably wouldn't want to say that. That wouldn't technically be true. Yeah, they can't be adjacent and opposite at the same time. Oh, and actually, I'm sorry, it did say, I misread it. It said they can't form a linear pair, but that's the same idea as that is what I showed there in the blue. Linear pairs have to form a straight line and be adjacent to each other. And like we just said, you can't be both adjacent and opposite. So sorry. Overall, that's true. Just kind of said it the wrong way. All right, let's look at 37. Help me, guys, help me. All right, 37, another true or false. If a ray divides an angle into two complementary angles, then the original angle is a right angle. So in other words, if there's an angle and you have a ray that's going to divide it into complementary. So in other words, if I have angle 1 and 2, 1 and 2 equal 90 degrees. It says, therefore, those two angles the original angle has to be 90. Well, is it possible to cut something into two pieces, have it be complementary and add up to 90, but not be a right angle? No. So that means what it's saying here has to be true. If I'm going to divide up two complementary angles, I have to have started with something that equaled 90, which is a right angle. So 37 is in fact true. Which then brings us to our last one, number 41. Number 41, our multiple choice problem, another comparison problem. And I wanted to do this one just because the way it's written might confuse you, and I just wanted to encourage you, it's not that difficult. It says the measurement of angle A equals 3y, and then the measurement of angle B equals 2m. It says this right here, it has this 2m angle A. All that means is that other angle is twice as big. It's twice as big as the measurement of angle A. And so it says find the value of y that makes them supplementary. Excuse me, that makes angle A supplementary to B. So in other words, we're talking about supplementary angles, which means they form a linear pair. They look like this, 180 degrees total. And it says that angle A, we'll call this angle A over here, is 3y. And it says that angle B is twice as big as angle A. So what's twice as big as 3y? Well, 2 times 3y, or 6y. So B is twice as big as angle A. Now that I've labeled it, and I can see that together, they're going to be supplementary, not complementary, but supplementary. They add up to 180. I can write an equation, because I can see that, well, that means that angle A plus angle B, who's twice as big, together they equal 180. And so now we're ready to rock and roll. I have 9y's, because I had 3y's plus 6y's, equals 180. I'm going to divide. Instead of multiplying by 9, I'll divide by 9. Cancels out. And so I'm left with y equals 20. And it asks for what value of y makes them supplementary to each other. Okay, so I found y, it's 20, and I can see that that is letter C. Okay, there we go, another comparison problem. And then again, I highly recommend when you're reading these things and you feel a little lost, sketch it out, carefully label it, and then you can begin to see the relationships. Alrighty, appreciate your attention. Hopefully this is helping. Reach out if you need any sort of help whatsoever. I'm happy to do it.